This video brings you the ATR8300. This video consists of the following parts. The first is how the instrument is assembled, software installation method and various functions. There are also inspection procedures and troubleshooting methods. And then we are going to assemble the instruments. Align the loading platform with the guide rail on the microscope and mount it from top to bottom. One hand supports the loading platform. Then tighten the setting screws with the hex wrench. Here, we should pay attention to the distance between the loading platform and the mirror seat. Prevent collision between the lens and the loading platform during use. Then connect the loading platform drive line A. Align the port and plug it in. Tighten the fixing screws. Here note that line A drives the loading platform to move from side to side. Line B drives the loading platform forward and backward. In the same way, the loading platform drive line B is connected. A B line must not be connected backwards. Next, install the lens. Choose the lens multiple according to your needs. Gently screw the lens into the lens converter, and then tighten it. The lens is set up. Switch the lens to the center by turning the converter. Now we connect the spectrometer to the microscope. Plug one end of the control signal line into the output interface of the spectrometer control signal. The other end is inserted into the control signal input interface of the microscope. Connect the microscope lighting power cord. Small head insert spectrometer lighting power output. Power input for the illumination of the trailhead microscope. The USB cable is plugged into the spectrometer and the computer. Another USB cable connects one end to a microscope and the other to a computer. Plug the power cable into the 24V DC port of the spectrometer. Finally, the optical fiber is connected to the spectrometer. Insert the white optical fiber into the laser interface. Tighten the nut. Insert the silver signal cable into the signal port. OK, our ATR8300 has been assembled. Press the power button and the indicator light will turn on successfully. Now install the software. Double-click to open the folder. Select driver install first. Click device driver. Click virtual COM port driver. Choose x64 or x8-bit software depending on your computer's operating system. Click on the next page. Click Finish when the installation is complete. After the software is installed, install the camera driver. Select the camera driver file. Click on the Setup file. Select the installer application. Click OK. Select OK. Now the software is all installed. Then open the optical Raman Microscope v3.2. Find the optical Raman Microscope app. Double-click to open the optical Raman Microscope application. Once the application opens properly, it is installed. Then set the corresponding model according to the instrument version. Click the menu bar Settings. Select Model Settings. Enter the password optical888. Click OK. Select the corresponding model. Laser power is selected according to the excitation wavelengths of the instrument. So let's start testing. Calcium carbonate was used as the test sample. Place the sample to be tested on the loading platform with the lens. Select the lens multiple based on the mounted lens. Set the moving step of the loading platform. Click 20x lens to start autofocus. The microscope began to autofocus. Autofocus is complete. Adjust parameters. Select the data type. generally choose to deduct dark bottom data. The collection mode is accurate collection. Adjust the appropriate integration time. Adjust the appropriate laser power. The average number of spectral collections, continuous collection interval, temperature of refrigeration, signal-to-noise ratio and intensity threshold, modify as needed. Click single collection to start detection. Completion of collection. The list of spectra collected can be viewed in the lower right corner. Right mouse click to select a spectral data to modify the data name. Click Peak Search to quickly find characteristic peaks. The upper left menu bar can save the spectral data. A variety of saving methods can be selected. Generally, the selected spectral data is saved. The value can be TXT or CSV. Click Continuous Collection to collect spectral data continuously. On the left side, you can view the lens picture and capture picture. Click Stop Collection to stop continuous collection. Operations of the mapping function. Select a feature peak imaging range. Click on the macro area. Choose an area. Determine the number of points collected. Click OK. Click Scan Imaging. Start to collect the collection points of the selected area. The characteristic peak intensity of the selected region can be judged by the false color image in the lower left corner. The red area represents a point with a high characteristic peak intensity. The blue area represents the point with low characteristic peak intensity. This trend change can see whether the test sample is uniform. Concentration distribution. Wide area scanning function. Click Experiment Wizard. Set the scanning start and point. Click Back. Click to confirm the starting point. Modify the X, Y axis parameter. Click to move. Click to confirm destination. Finally, click Start Image Mosaic. The progress bar displays the collection and stitching progress. The speed of collection is related to the set integration time. Completion of collection. Click in Collect area. Drag the mouse to select the area you want to scan. You can also select the number of scan points by modifying the SY step. Click OK. Click Scan Capture. Then the software will scan automatically according to the scan lines we set up. The points collected can be seen in the lens scanning screen. False color imaging and false color evaluation are the same as microscope imaging. Displays the intensity trend for the selected wave number range. Completion of collection. Here are some basic features. Control lens lighting. Clear spectrum diagram. Undo. Setting a collection scheme. You can add your own spectrum gallery. Match with Atlas library material. Setting function. Camera settings adjust camera parameters. XY unit. Number of curves. Wave number correction. False color calculation settings. Lens setting. Set the spectrum naming. Adjust the x-axis parameters. Expand the spectrum list on the right. Expand the spectrum control panel. The scan results match. Open the history view bar in the lower left corner. Open and close the left lens screen. Turn on the laser. Function of algorithm. Smooth and optimizable curves. Derivative. Normalize. Baseline correction. Constant arithmetic. Spectrum arithmetic. Method function can add the detection method tutorial. The language function can be switched between Chinese and English. Check the operation manual. The company homepage can be directly accessed from the official website of the company. About the system logs can be viewed. Here are some common questions. No port corresponding to the spectrometer was found. When the device function was opened, exit auto spectral for Raman v1.7 Spectrum software. Users install STM32 USB to serial port driver. Driver path is installation package USB to serial port driver pin stack 86 EXE. After the USB to serial port driver is installed, rerun the opto spectral for Raman v1.7 EXE program and the corresponding port of the spectrometer can be found in the port of the device. The collection time of the instrument is too long, and the collection result does not appear. Check whether the integration time is set too long or the average number of times is set too high. If the non-human set too long, then the communication data line may be loose, resulting in communication interruption. Disconnect and connect the USB cable and power cable. Reinstall the driver. Check whether the device is successfully connected or click collect successfully. Click collect, cannot collect. Ask to select the area set parameters. Before each collection, the collection location should be selected, no matter what version of ATR8300 you buy. If you buy ATR8300 BS or ATR8300 AF, you can choose the point at will, and the point position of each radiation is the same. If an area is selected with the two instruments, The instruments will take continuous measurements at the same point. For the first collection, the acquisition parameters must be set first, and the appropriate laser power and integration time should be set according to the difficulty of the laser burn. On the sample, for example, the biological, black and light absorbing samples should be set at a lower laser power. The recommended excitation wavelengths of 785 nm is below 50 mu, and the recommended excitation wavelength of 532 nm is below 15 mu. Low laser power with long integration time is recommended for samples that burn easily and have low Raman signal. Software can't control the sample table and can't autofocus. ATR8300BS and ATR8300AF cannot be used to control the sample table, while ATR8300BS cannot autofocus. ATR8300MP cannot control the sample table. You can check whether the step setting value is small step 2000 is a rotation. Confirm that the sample table is not moving. Try to power off the instrument and turn off the software. Reinsert the DBR5 while sequence wire, and turn on the instrument and software again. It is recommended that you manually adjust the sample table to the fast focusing position, which can greatly reduce the autofocusing time. Using samples with uneven surfaces can also reduce the accuracy of autofocus. That's the end of this video.